Hello and welcome back to Professional Tutors, the British online school. We are a unique team of qualified and dedicated teachers here to help our students to reach their full potential. In today's lesson, we're going to talk about shapes of molecules. What we'll learn in this topic, we'll look at some prior knowledge. That's the most important one. We're going to look at the electron pair repulsion theory, and we look at the shapes of some simple molecules or the regular shapes, and then we look at the shapes of molecules with lone pairs of electrons. Then we look at some more complex shapes, which is shapes of ions. Then talk about the shapes of the molecules with double bonds. And we'll look at some exam questions and checklist. Before you start, it would be helpful if we go back and look at the definition of a covalent bond. That's a bond by sharing electrons. We'll look at what is a lone pair. So that's a pair of electrons which is not involved in a covalent bond. And we all know this, that the like charges, they repel each other. And here we're talking about the repulsion between electrons. Right, so we have to talk about electron pair repulsion theory, and that's really important for the exam. The whole of the topic is based upon this theory. And that theory says that the shape adopted by a simple molecule or ion is that which keeps repulsive forces to the minimum. What does that mean? That the bonds, which are made up of electrons, and there are repulsions between the bonds. So let's say the shape of the molecule is going to be in such a way as to maximize the distance between the bonds to minimize the repulsion, basically. So if they are molecules which contain covalent bonds, and we know that covalent bonds they are made up of a pair of electrons, and each bond will repel the other bond. So bond, instead of having this shape, this one would be kind of the shape of three bonds around the central metal atom is going to be something like that, trigonal planar. So bonds will therefore push each other. So the bonds, they're going to push each other as far apart as possible to reduce the repulsive forces. And because the repulsions are equal, the bonds will also be equally spaced. So in this case, all the bonds, they are equally spaced. In this case, it's not. So bonds are closer together here. So repulsive forces are greater as well. Now here, bonds are further away from each other, so repulsive forces are less as well. And in this case, all the bonds, they are equally spaced. They're spaced out as far apart as possible. Now, here we're going to look at the shapes of the molecules without a lone pair. So molecules of ions which got only the bond pairs, there are no lone pairs here at all. So only bond pair of electrons, they fit into a set of standard shapes. All the bond pair repulsions are equal. Now we have to make a note of this. So that is going to be a part of your 1 mark multiple choice question. So all you need to do is just to count up the number of bonds around the central metal or central atom. It could be metal, could be non-metal, right? So if there are only 2 bonds around the central atom, like 1 bond and second bond, the shape is always going to be linear. Linear means that's going to be a straight line, and the bond angle is going to be 180 degrees. And the example of this is BeCl2. So in this case, beryllium is going to be the central atom and one chlorine on one side and the second chlorine on the second side. If there are 3 bonds around the central atom, then the shape is going to be trigonal planar. Again, we're going to look at these shapes in detail. How do they look like? So if the 3 bond pairs, then the shape is going to be trigonal planar, and the bond angle is going to be 120 degrees between each bond, and the example is going to be AlCl3. Now, if there are 4 bond pairs around the central atom, then the shape is going to be tetrahedral. Again, we're going to discuss these shapes in detail. We'll look at how does a tetrahedron actually looks like. We have to memorize these bond angles. So if the shape is tetrahedral, then the bond angle is going to be 109.5 degrees. It has to be written like this. And the example is CH4. If there are 5 bonds around the central atom, the shape is going to be trigonal bipyramidal. Again, we're going to look at the shape in a minute. And there are 2 types of bond angles there, 90 degrees and 120 degrees. Again, we're going to discuss these in detail, and the example for this is going to be PCl5. If there are 6 bond pairs around the central atom, the shape is going to be an octahedral, and all the bond angles are going to be 90 degrees, and example is SF6. So from this slide, all you need to memorize or remember: how many bond pairs, what's the shape, what's the bond angle, and these ones we can work them out. So now just have a look at some examples. Molecules with the lone pairs. Now, a lone pair is a pair of electrons which is not involved in a covalent bond. So if a molecule or ion has a lone pair, that is how we represent a lone pair on the central atom. The shapes are slightly distorted. They're slightly different. They're a bit more squeezed. And why is that? Because the extra repulsion caused by the lone pairs. Now we have to remember this one there. Now that is a part of your 1-mark multiple choice question as well. The repulsion between lone pair and a lone pair is the greatest one. And then repulsion between the lone pair and a bond pair, and the repulsion between a bond pair and a bond pair is the least. So less repulsion when it's a bond pair and a bond pair, and then it increases if there's 1 lone pair and 1 bond pair, and that is where the repulsions are maximum or the strongest if there are 2 or more lone pairs. So as a result of extra repulsion between the lone pairs, 2 lone pairs or a lone pair and a bond pair, the bond angles, they tend to be slightly less. The molecule is kind of squeezed. So bond angle tend to be slightly less as the bonds are squeezed together. Again, we're going to look at these examples in detail. Okay, so let's have a look at the example of beryllium chloride. Now, beryllium has 2 electrons to pair up, 1 and 2. The chlorine needs only 1 electron for the octet. Now, octet means having 8 electrons in the outer shell. So they're going to form 2 covalent bonds. And if we go back and see that there are 2 covalent bonds, that means the shape is going to be linear and the bond angle is going to be 180 degrees. So that is how we're going to draw that in exam. So bond pairs, 2 bond pairs, Is there any lone pair? No, there's no lone pair at all. And we know from the previous slide that if there are two bond pairs, the shape is going to be linear and the bond angle is going to be 180 degrees. Right, so just have a look at this animation here. So we know two bonds, linear. When you add a third one, that is going to repel these two bonds here, and the shape is going to be distorted. So there's an extra repulsion, or there's extra bond has been added, and that bond, the repulsion between these bonds and these bonds, is going to push these two bonds downwards. So, and that's going to be what you call a trigonal planar shape, and the bond angle is going to be 120 degrees. Right, so in this example, we've got aluminium. It's got 3 electrons to pair up there in the outer shell. The chlorine has got 7 in the outer shell. It just needs 1 more electron to have a full outer shell, which is complete octet. That is how they're going to pair up. So 3 covalent bonds are formed, and we've just seen that animation when there are 3 bond pairs. And also from our very first slide, what we discussed, if there are 3 bond pairs around the central atom, the shape is going to be trigonal planar. Just simply draw a triangle, that's what it is. And the bond angle is going to be 120 degrees. So in exam, you have to write down how many bond pairs are there, how many lone pairs are there, what's the shape of the molecule, what's the bond angle, and you have to draw the shape as well. It doesn't really matter which way you draw the triangle. So as long as you draw a triangle and the shape and the bond angle is correct, which is 120 degrees in this case, you will get full marks there. Now let's have a look at this. This is trigonal planar. What if we add another bond to trigonal planar? So when we're going to add the 4th bond, this bond is going to push these 3 bonds downwards, and that will form a tetrahedron. So we start with 120 degrees. So that bond is going to push these 3 bonds down, and the bond angle now is going to be 109.5 degrees. And that is the shape of a tetrahedron. So if there are 4 bonds around the central atom, the shape is going to be tetrahedral, and the bond angle is going to be 109.5 degrees. Just have a look at the example of methane, which is CH4. Again, what you have to do is simply look at how many bond pairs are there around the carbon atom. So carbon has 4 electrons to pair up, hydrogen 1 electron to complete the shell. And so in this case, you have 4 bond pairs around carbon atom, no lone pair. And we know from our previous slide that if there are 4 bond pairs, the shape is going to be tetrahedral shape, and the bond angle is very specific in this case. It's 109.5 degrees, so make sure you write 109.5. If you write 109, 110, they're going to cross it out. So bond angle is going to be 109.5 degrees, and that is how you are going to draw the shape. They've shown here 1 angle, but all the angles are the same. So every single angle is going to be 109.5 degrees. And that is how a tetrahedron or tetrahedral shape looks like. It's like a tripod. Right, in this example, we've got phosphorus fluoride. So phosphorus has 5 electrons to pair up. Fluorine needs only 1 electron to complete its outer shell. Phosphorus can also use d orbital to expand its octet. Again, that is not really important at this stage. So if we go back and look at our previous slides, if there are 5 bond pairs around the central metal atom, the shape is going to be trigonal bipyramidal. So in this case, 5 bond pairs, no lone pair. The shape is going to be trigonal bipyramidal, and there are 2 types of angles. The way you're going to draw the shape trigonal bipyramidal, simply draw a triangle, and 1 bond on the top, 1 bond at the bottom. Now this is a flat surface. This is a planar. That's a planar shape, and we know from previous example, for trigonal planar, the bond angle is going to be 120 degrees. Now this bond is going up and this bond is going down on the planar shape. So this bond is going to be 90 degrees, and the bond here is going to be 90 degrees as well. So for this example, there will be 2 sets of bonds, 120 degrees and 90 degrees. Right, in this example, we've got sulfur fluoride. So sulfur has got 6 electrons to pair up. Fluorine needs 1 electron to complete. So we know what to do. Just always look at how many bond pairs are there. So in this case, there's 6 bond pairs. There are no lone pairs at all, and the shape is going to be octahedral. So simply draw a square and 1 bond on the top and 1 bond at the bottom, and all the bond angles are going to be exactly the same. They're all going to be 90 degrees. That's your octahedral shape. And that is what an octahedron looks like. It's got 4 edges on the top, 4 sides on the top, 4 at the bottom, so 8 in total. That's why it's called an octahedral shape. So now we have discussed about the simple molecules. The next thing, we're going to look at the molecules which involve a lone pair, 1 or more lone pair of electrons. Again, a quick recap. That is what we need to remember. The repulsion between a bond pair and a bond pair is the least, and the repulsion between a lone pair and a lone pair is the strongest one. So, and now we'll look at, so as a result of strong repulsions between lone pairs or bond pairs, the shapes we have discussed, they will keep more or less the same, but the bond angle is going to change because these lone pairs, they're going to squeeze the other bonds because of the greater repulsion between the lone pairs and the bond pairs, or the 2 or more lone pairs there. So in this case, we're going to look at the example of ammonia. The ammonia has 5 electrons in its outer shell, so 5 electrons, and we know the formula of ammonia is NH3. So out of 5 electrons, 3 of them are involved in a covalent bond with hydrogen. So 1 covalent bond here, 1 there, and 1 there. So, but these 2 electrons there, they are not involved in any chemical bond. So that means they are the lone pair of electrons. So it cannot pair up all 5, because if that's the case, it's going to have more than 8 electrons in the outer shell, and that's not possible. So it pair up only 3 electrons out of 5. So it's going to end up with 3 covalent bonds and a pair of non-bonded electron, which is basically a lone pair. Now the total number of electron pairs is 4. The shape is similar to tetrahedron, but we know that the lone pair bond pair repulsions, they're greater than bond pair and bond pair repulsions. Now again, we have do that little calculation on the side. So in the whole molecule of ammonia, there are 3 bond pairs and there is 1 lone pair. So in total, there are 4 pairs. So 4 means it's going to be a tetrahedral shape. So the basic shape is going to be more or less the same. Now where the things are going to change. Now that is how. So that's a tetrahedron. And these are 3 bond pairs. And that's 1 lone pair. Now because of the greater repulsion between the lone pair and the bond pairs, that lone pair is going to squeeze these 3 bond pairs a bit further. We know the bond angle in a regular tetrahedron is 109.5. Now because of greater repulsion, because of the lone pair, the bond angle is going to be reduced as well. It's gone from 109.5 degrees to 107 degrees. And we don't normally represent that the top bit here. So that's simply going to be pyramidal because the top part is gone. So because there's no bond there. So the new shape which we will have, that is still based upon the tetrahedral shape. 2 things have changed. One, the bond angle has gone from 109.5 to 107, and the top bit is gone from the tetrahedron, and all we left with here is a pyramid. So that's going to be pyramidal shape. Let's have a look at the example of water. In case of water, with oxygen, it's got 6 electrons in the outer shell. It cannot pair up all 6 because maximum number of electrons are allowed, which are allowed is 8. It can only pair up with 2 hydrogen atoms. In this case, we can see there's 1 covalent bond here, 1 covalent bond here. Now this pair of electron and this pair of electrons, they are not involved in any covalent bond. So in this case, in case of water, there'll be 2 lone pairs of electrons. Again, if you look at bond pairs are going to be 2, lone pairs 2. So total number of pairs are going to be 4. And we know that if there are 4 pairs, then the shape is going to be tetrahedral. But where it's going to be different, we know this, that lone pair repulsion is greater than lone pair bond pair repulsions, and which is again greater than bond pair and bond pair repulsions. The OH bonds, these 2 covalent bonds, they are pushed even closer. So the basic shape where we started is tetrahedral. Because of these 2 lone pairs, these 2 bonds are squeezed further. So in ammonia, the bond has gone from 109.5 to 107. And now because of even greater repulsion, the bond angle is going to be squeezed again. And the new bond angle is going to be 104.5 degrees. But the basic principle remains the same. So we start with the tetrahedral. And as we said that we don't include the lone pairs in the final shape. So that is how you represent the lone pair of electrons. And the name of the shape is angular or simply V shape, because that's forming a V, upside down V. So V shape, angular or bent. So you can say that way. And these are the ammonia and water are one of the important questions they're going to ask you in exam. Thanks for watching. If you find the information useful, please subscribe, share, and like the video.